So if you're interested in security and reliability engineering, especially in the world of AI and machine learning, this is a very important video. I'm going to talk about the three major areas of security within machine learning and AI that is going to, uh, very, very important to be aware of. Since the AI models are dealing with the safety and security of the public and the people, it is essential to understand these threats. Because as I said, for instance, in the case of autonomous vehicles, the car is, dealing with the safety of the public. And in terms of, many things like facial recognition and other things, dealing with the public security and information security. And the adversaries are going to be able to find out the vulnerability within your model and attack them using those vulnerabilities. And especially when you give permission to these AI agents and the permissions level is going to higher and higher, this threats and the levels of threats is going to be corresponding with that. So stay tuned. I'm going to talk about, in details about these levels of security. In terms of securing is artificial intelligence, it is fundamentally different challenge than securing traditional software. In the world of AI, the vulnerabilities aren't just in the code; they are baked into the very way these systems learn, perceives, and also reason. We generally look at these threats through three distinct lenses, which are called one, poisoning, number two is evasion, and number three is privacy. First, there is this long game poisoning attack, which is basically happening during the training phase, before the AI is even born. So imagine like an adversary is trying to contaminate the dataset, injecting poison attacks that look normal but contain a hidden bias or a secret backdoor. By doing this, the attacker isn't just breaking the model, they are teaching it to be wrong. They might train a security system to ignore a specific person or a spam filter to permit a specific type of malicious link. Once that poison is in the foundation of the model is compromised from the day one, and often without the developers even realizing it. Then there is this evasion attack, which is a more immediate threat. This occurs during the inference phase. After the model has been deployed into the world, here the attacker doesn't change the AI itself. Instead, they manipulate the input to trick it. Think of it as like an optical illusion for machines. By adding a layer of mathematical noise, like pixels that are invisible to a human eye but catastrophic for a neural network, an attacker can make a self-driving car misinterpret a stop sign for a facial recognition system, mistake a stranger for a CEO. These adversarial examples exploit the fact that AI doesn't see the world the way we do it. It sees a high dimensional landscape of probability that can be easily tilted. One example of it is some PhD researchers basically put a specifically designed tag on a stop sign, and it was maybe this big and maybe a 20th or 10th of the size of the stop sign itself. And instead of reading it as a stop sign, the machine learning model read it as a speed limit. So instead of stopping, it would continue driving. And you can imagine what kind of public safety issues it would create. Or, it something for in terms of facial recognition, there was something that the adversary would put on the person's face and it would recognize as someone else, because machines do not see the pictures or the images as we see it. Just a small change in like a specifically designed pixel can trigger the machine to recognize something instead of something else. Finally, the number three is the battle for the brain of the model itself. So basically, it's a privacy and extraction attack. These focus on theft. In a model extraction attack, an adversary queries the AI maybe 1,000 of times or even more, recording the output to reverse engineer and clone the logic without the cost of research and development. So what happens is that the adversary will, run a series of tests on the model, put the input and output, and compares them to and keeps record of every input and output. And by collecting these samples, what happens is that it recreates the model itself. So that would be the model extraction attack. And in a privacy attack, they attempt to invert the model, probing it to see if a specific person's private medical record or personal data was used in the training data set. It's a hunt for the intellectual property and the sensitive history that makes the AI valuable in the first place. So once they extract the model, they can, use all sorts of things. Maybe they put certain inputs in it, and then what the output looks like, or vice versa. So once they have the model, they kind of clone the model. They're able to do all sorts of things with it. So when we build AI, we aren't just building a tool because of the ubiquity of the AI models nowadays. We are building an attack surface, especially with the levels of permission, as I mentioned. Understand these three vectors. It is the only way we can move from simply creating intelligent systems to creating resilient ones. To summarize, there are three types of attacks. One is poisoning attack, which is during the training phase. Evasion happens during the inference phase. And the model extraction basically is when the attacker is trying to extract the model by repeating the running the model over and over, saving the inputs and outputs. And all of them, as I said, pose serious security and safety risks to the public, to the people using it. And it's very important to understand it, try to, uh, design for these risks and move on from there. Thank you for watching. I'll see you in the next video.